delay due to network issues. So today is the last topic of solid state chemistry chapter, and that is also one of the important topics, that is magnetic properties of solids. In the previous class yesterday we have come across electrical properties of solids, and in this class again one more important set of properties of solids are going to be discussed. They are magnetic properties of solids. And we have seen electric properties of solids are due to the migration or movement of delocalized electrons of a material, of a metal, or of any solid material. And similarly, here magnetic properties of solids are also due to electrons present in atoms of the material. Here we know every solid possesses atoms in it, and all atoms contains electrons in them, and these electrons, they move in respective orbits in those particular atoms. So because of the movement of these electrons in their own orbits, each and every atom and the substance possess magnetic properties. So each and every substance contain, or it exists with some magnitude of magnetic properties in it. Here in the picture you can see an atom which contains nucleus at the center, surrounded by orbits. So you can see the innermost spherical one, 1s, and the next one is 2s subshell, and the next 3s subshell, and you can see orbitals of different shapes, dumbbell shapes orbitals are there. And in those orbits, electrons are present. So we know in an atom, electrons present and revolve around the nucleus in their energy levels or shells or orbits. Due to the movement of electrons around the nucleus in their orbits and around themselves, it results in the formation or execution of magnetic property of it. Therefore, each electron present inside an atom behaves like a tiny magnet. What are those reasons which make the electron a tiny magnet? There are two reasons. The first one is its orbital motion around the nucleus. And the second reason is its spin around its own axis. So to understand these two concepts better, we can assume, or we can correlate it with our solar system. Our solar system has sun at the center, which is surrounded by planets. And if you consider our Earth, Earth is revolving around the nucleus in its particular orbit. The same way, electrons revolve around the nucleus in particular orbit or shell or energy level. Also, as our Earth revolve around the nucleus, as well as it rotates about itself. The same way, electrons revolve around the nucleus and rotate themselves about their own axis. So, hope you understood better. So, these are the two reasons which results in the magnetic properties of solids. So, magnetic properties of solids are due to electrons present in atoms. Each electron present in atom acts like a tiny magnet, small magnet. What made it to act as a magnet? There are two reasons for that. First reason is the electron's orbital motion around the nucleus. And the second reason is its spin around its own axis. We know that each electron has two spins. One is in clockwise direction and the other is in anti-clockwise direction. So every electron present in an atom rotates about itself, about its own axis in two different ways, that is in clockwise spin or anti-clockwise spin. So ఒక సాలిడ్ మెటీరియల్లో ఆటమ్స్ ఉంటాయి. ఈ ఆటమ్స్ లో ఉన్న ఎలక్ట్రాన్స్ వాటి మూమెంట్ వల్ల టైనీ మ్యాగ్నెట్స్ లాగా ఎగ్జిస్ట్ అవుతాయి. ఎందుకు అవి మ్యాగ్నెట్స్ లాగా బిహేవ్ చేస్తున్నాయంటే టూ రీజన్స్ ఉన్నాయి. ఒకటి, ఆ ఎలక్ట్రాన్ న్యూక్లియస్ చుట్టూ దాని ఓన్ ఆర్బిట్ లో తిరుగుతుంటుంది, అదొక రీజన్. ఇంకొక రీజన్ ఏంటి, ఎలక్ట్రాన్ దాని చుట్టూ అదే తిరుగుతూ రివాల్వ్ అవుతుంది న్యూక్లియస్ చుట్టూ. సో ఈ టూ రీజన్స్ వల్ల ప్రతి ఎలక్ట్రాన్ కూడా మ్యాగ్నెట్ లాగా బిహేవ్ చేస్తుంది. సో ఈ పిక్చర్ లో మీరు సెంటర్ న్యూక్లియస్ చూడొచ్చు, which is surrounded by 1s orbital, 2s orbital and 3s orbital with 2p orbitals which are seen in dumbbell shape. S orbitals are all in spherical shape. So movement of electrons around the nucleus may be in spherical shape or dumbbell shape or double dumbbell shape, etc. But spin of electrons is in two ways, either in clockwise spin or anti-clockwise spin. Because of this kind of movement of electrons present in atoms, they exhibit magnetic properties. So here, this is the picture which again clearly explains how electron movement is observed inside an atom. In the left hand side, or the left picture shows orbital motion around the nucleus. See here, the central spot is nucleus, atomic nucleus, and about this magnetic moment is arising due to the movement of electron or the revolving electron which is going about its own orbit. So here electron is revolving around the nucleus in its own energy level. Because of this movement, magnetic moment is existing or it is arising inside it. This right picture shows the spin of the electron about its own axis. So here this is the tiny electron, and this electron is rotating by its own axis. So here you can see the small arrow inside the blue colored sphere, a blue colored circle, which shows direction of spin. So here in this particular case, electron is rotating by itself in anti-clockwise spin. So because of these two types of movements of electrons present in the atom, magnetic properties are shown. Therefore, each electron has a permanent spin and an orbital magnetic moment associated with it. So this electron itself is a very minute particle, and its motion about its nucleus is also comparatively small. Therefore, the magnitude of magnetic moment is very, very small. So usually magnetic moments are measured in terms of Bohr magneton. Bohr magneton symbol can be represented by mu suffix d. One Bohr magneton value is equal to 9.27 into 10 to the power of minus 24 ampere meter square. On the basis of their magnetic properties, substances or solids can be classified into 5 categories. They are paramagnetic substances, diamagnetic substances, ferromagnetic substances, antiferromagnetic substances, and ferrimagnetic substances. So here the first type of magnetism is paramagnetism. Paramagnetic substances are weakly attracted by magnetic field. And this paramagnetic nature of substances is due to the presence of one or more unpaired electrons present in the atom. Why only unpaired electrons are showing magnetic property? Because if there are two electrons inside one particular orbit, we know that each orbital can accommodate two electrons of opposite spins. If there are paired electrons in an orbital, then spin energy caused by one electron is cancelled by the other electron because of equal and opposite directions, and therefore only unpaired electrons causes magnetic property. More the number of unpaired electrons present in an atom, greater will be the magnetic property exhibited by it. Therefore, in paramagnetic substances, there will be less number of unpaired electrons, maybe one or two unpaired electrons, which result in weak magnetic field. When magnetic field is applied on such kind of substances, what happens? You can see this in this picture. In the left hand side, you can see the random arrangement of electrons or ions in the solid. So they are all, arrow marks are all seen in all possible different directions in the absence of magnetic field. But once magnetic field is applied on this particular solid, you can see the right hand side picture. In this picture, all of them, or we can say most of them, are turned to one particular line. So they are all aligned in one particular direction. And of course, you can see few of them which are seen in downward direction. Many are seen in upward arrow mark and few are showing downward arrow marks. So, in paramagnetic substances, by applying external magnetic field, these ions or electrons are aligned in one particular direction. And once if the external magnetic field is removed from the substance, then again they lose their magnetic property and they come back to their original position. Examples, we can take oxygen, Cu2 plus, Fe3 plus, Cr3 plus. These are all few examples for those substances which exhibit paramagnetic property. So paramagnetic materials exhibit magnetism only under the influence of magnetic field. In the absence of magnetic field, they rearrange themselves to get their original arrangement. సో ఎక్స్టర్నల్ మ్యాగ్నెటిక్ ఫోర్స్ అప్లై చేసినప్పుడు ఏమవుతుంది, వేరియస్ డైరెక్షన్స్ లో ఉన్న అయాన్స్ ఎలక్ట్రాన్స్ అన్ని ఒక పర్టికులర్ డైరెక్షన్ లో రావడానికి ట్రై చేస్తాయి. ఇవి ఒక రెగ్యులర్ షేప్ లో రావడానికి ట్రై చేస్తాయి అన్నమాట. అదే ఎక్స్టర్నల్ ఫీల్డ్ రిమూవ్ చేసినప్పుడు మళ్ళీ ముందు ఏ విధంగా ఉన్నాయో ఆ విధంగా ముందున్న విధంగా తయారవుతాయి. సో దిస్ ఇస్ కాల్డ్ పారామాగ్నెటిక్ ప్రాపర్టీ. సో paramagnetism ఎందువల్ల వస్తుంది? Because of the presence of less number of or one or more unpaired electrons present in the atom. Next magnetic property is diamagnetism. Diamagnetic substances are weakly repelled by a magnetic field. It is shown by those substances in which all electrons are paired. Or you can say, if there are no unpaired electrons in an atom, such substances exhibits diamagnetic nature. So, as we have seen earlier, if you consider an orbital having two electrons which are oppositely paired, which have opposite spins, the spin due to one electron is cancelled by the spin due to the other electron. Because of that, they lose their magnetic character. Therefore, diamagnetic substances are weakly repelled by magnetic field. Examples for that are water molecules, sodium chloride, benzene, etc. సో డయామాగ్నెటిజం అనే ప్రాపర్టీ అంటే ఏంటి, మ్యాగ్నెటిక్ ఫీల్డ్ని ఏదైతే వీక్లీ రిపెల్ చేయగలుగుతుందో దాన్ని డయామాగ్నెటిక్ సబ్స్టెన్స్ అంటాము. ఆ సబ్స్టెన్సెస్ అలా ఎందుకు బిహేవ్ చేస్తాయి, వేటిలో అయితే అన్పేడ్ ఎలక్ట్రాన్స్ జీరో అసలు లేకుండా ఉంటాయో అలాంటివి డయామాగ్నెటిక్ ప్రాపర్టీని ఎగ్జిబిట్ చేస్తాయి. Ferromagnetism. So this is the third type of magnetism shown by solid substances. Ferromagnetic substances are strongly attracted by the magnetic field, and they can be permanently magnetized. In the sense, so already we have seen paramagnetism is due to the presence of one or more unpaired electrons present. But ferromagnetism is due to more number of unpaired electrons present in the atom. Greater the number of unpaired electrons present, greater is the magnetic property exhibited by it. Therefore, they act as strong magnets. Here we come across another new term called domain. If you want to know how these electrons or particles are exhibiting ferromagnetism, we should know the arrangement of domains in substances. What are these domains? Ions of ferromagnetic substances group together in small regions to act like a tiny magnet. This small magnetic region is called domain. ఫెరోమాగ్నెటిక్ సబ్స్టెన్సెస్ లో ఉన్న అయాన్స్ కొన్ని ఒక గ్రూప్ గా ఏర్పడతాయి. అలా ఏర్పడిన గ్రూప్స్ అన్ని స్మాల్ మ్యాగ్నెట్స్ లాగా యాక్ట్ చేస్తాయి. అలాంటి చిన్న గ్రూప్స్ వాటిని డొమైన్స్ అంటారు. మ్యాగ్నెటిక్ ఫీల్డ్ అప్లై చేసినప్పుడు ఏమవుతుంది, ఈ డొమైన్స్ అన్ని కూడా సేమ్ డైరెక్షన్ లో ఓరియంట్ అవుతాయి. సో హియర్ when an external magnetic field is applied on ferromagnetic substances, you can see the orientation of all domains in one particular direction. And even this direction of domains is retained after the removal of magnetic field, external magnetic field. So you can see the same in this picture. All upward arrow marks are seen. So this is the kind of arrangement that is seen in ferromagnetic substances after applying external magnetic field. Because of large number of unpaired electrons present in them, even after removing external magnetic field upon the substance, it retains its magnetic property. Such type of substances are called ferromagnetic substances. Example, we have iron, cobalt, nickel, gadolinium, chromium oxide, etc. as examples that can be quoted for this kind of substances. So, ఎక్కువ unpaired electrons ఉంటే magnetic property కూడా ఎక్కువగా ఉంటుంది. సో, ఈ ఎక్కువ unpaired electrons ఉండడం వల్ల magnetic moment ఎక్కువ ఉంటుంది. So, they are strongly attracted by the magnetic field. Here in this picture, it is more clearly picturized about the arrangement of electrons or ions present in the materials. So here the upward picture having blue colored arrows, it is those substances which exhibit paramagnetic property. So top left side, the picture shows in the absence of magnetic field, electrons or ions are arranged in very random directions. ఒక్కొక్కటి ఒక్కొక్క డైరెక్షన్ లో వేరే వేరే విధంగా అరేంజ్ అయి ఉన్నాయి. On the top right side, in this picture you can see in the presence of magnetic field how electrons are aligned in one particular direction. Maximum number of upward arrows are seen and very few downward arrows are also seen. Therefore, if the external magnetic field is once removed upon the substance, then all these aligned, regularly arranged particles will be returned back to their random positions. In the bottom left picture, you can see domains. So here you can come to a clarification about what is a domain. Here there are 4 portions seen in this particular picture of a solid, where group of ions are forming or collectively seen in one particular region, and they are oriented in one particular direction. But if you see all the 4 different domains, each of them have arrangement or alignment of their ions in different directions. So this is one set of ions grouped together to form a domain. This is another set. This is another set, and this is another set. There are 4 different sets of domains which are oriented in different directions in the absence of magnetic field. ఈ రెడ్ కలర్డ్ ఎలక్ట్రాన్స్ ఆర్ అయాన్స్ అన్ని కూడా ఒక గ్రూప్ ఫామ్ అయ్యి ఆ గ్రూప్ కూడా ఒక టైనీ మ్యాగ్నెట్ లాగా యాక్ట్ అవుతుంది అనమాట. సో ఈచ్ డొమైన్ యాక్ట్ యాస్ అ టైనీ మ్యాగ్నెట్. So this is the arrangement of domain directions in the absence of magnetic field. And if you see the other picture on the bottom right side, you can see the same 4 domains. When external magnetic field is applied on the substance, all 4 domains are oriented themselves in one particular direction as they are attracted by the magnetic field, external magnetic field. The 4 different domains kuda external magnetic field లేనప్పుడు వేరే వేరే డైరెక్షన్స్ లో ఉన్నాయి. ఎక్స్టర్నల్ మ్యాగ్నెటిక్ ఫీల్డ్ అప్లై చేసినప్పుడు అన్ని డొమైన్స్ కూడా ఒకే డైరెక్షన్ లో ఉన్నాయి. సో దీస్ ఆర్ 4 domains of or regions of the substance which are attracted by the magnetic field. సో ఇలాంటి వాటిని ferromagnetic substances అంటాం. And these ferromagnetic substances retain their magnetism even after removing external magnetic field. సో ఈ అలైన్మెంట్ ఏదైతే ఒకే డైరెక్షన్ లో రెగ్యులర్ గా అరేంజ్ అయిందో ఆ అలైన్మెంట్ అలాగే ఉంటుంది. బయట ఎక్స్టర్నల్ ఫీల్డ్ ని రిమూవ్ చేసేస్తే కూడా ఇలాగే ఉంటుంది. The next type of magnetic property is antiferromagnetism. Antiferromagnetic substance possess a net zero magnetic moment. So even these antiferromagnetic substances possess domains as that of which are seen similar in case of ferromagnetic substances, but direction of domains are in opposite directions, and therefore the resulting magnetic field will be zero. So here in this picture A, you can see ferromagnetism where all domains are aligned in upward direction. But in picture B, you can see antiferromagnetism where one arrow upwards, the next arrow downwards, and therefore magnetic moments of both of them are cancelled each other. Similarly, so if you observe here, alternate arrangement of domains in equal and opposite directions result in zero magnetic moment of the substance. Examples are manganese oxide, vanadium oxide. సో ఈ యాంటీఫెరోమాగ్నెటిజం అనేది వీటిలో కూడా ఫెరోమాగ్నెటిక్ సబ్స్టెన్సెస్ లాగా డొమైన్స్ అనేవి ఎగ్జిస్ట్ అవుతాయి. ఈ డొమైన్స్ ఉన్నా కూడా అవి ఈక్వల్ అండ్ ఆపోజిట్ డైరెక్షన్స్ లో ఉండడం వల్ల వాటి నెట్ మ్యాగ్నెటిక్ ప్రాపర్టీ అనేది జీరో అయిపోతుంది. Since these domains are oppositely oriented, they cancel out each other and result in zero magnetic moments. And the next magnetic property is ferrimagnetism. So ferromagnetism is different from ferrimagnetism. What is this? These are weakly attracted by the magnetic field compared to ferromagnetic substances. Why are they weakly attracted comparatively? They are seen, they can be understood by seeing this picture. So here this is the picture C, where you can see the alignment of different domains in different directions. Ferrimagnetic substance, 2 upward arrows, 1 downward arrow, again 2 upward arrows, 1 downward arrow. Therefore net resultant magnetic moment exists, but the value of it is less. Magnitude of magnetic moment is less because the orientation of domains is not equal and opposite. One is more and the other is less. And these ferrimagnetic substances lose magnetism upon heating and they become paramagnetic. Examples are magnetides and ferrites. సో ఫెర్రీమాగ్నెటిజంలో కూడా మనం డొమైన్స్ ని చూస్తాం. డొమైన్స్ అంటే ఏంటి? గ్రూప్ ఆఫ్ అయాన్స్ present in a region in which ions are oriented in one particular direction. They are called domains. ఈ డొమైన్స్ అనేవి ఫెరీ మ్యాగ్నెటిక్ సబ్స్టెన్సెస్ లో కూడా ఎగ్జిస్ట్ అవుతాయి. కానీ when an external magnetic field is applied upon it, few domains are in opposite direction and majority of domains are in different direction. సో ఈక్వల్ అండ్ ఆపోజిట్ డైరెక్షన్ లో అయితే ఉండవు. మెజారిటీ అనేవి అట్రాక్ట్ అవుతాయి, కొన్ని మాత్రం ఆపోజిట్ డైరెక్షన్ లో ఉంటాయి. సో రిజల్టెంట్ అనేది ఈక్వల్ అండ్ ఆపోజిట్ గా క్యాన్సిల్ అవ్వదు కాబట్టి నెట్ మ్యాగ్నెటిక్ మూమెంట్ అనేది ఎగ్జిస్ట్ అవుతుంది. If you see this in this picture, సెకండ్ మ్యాగ్నెటిక్ మూమెంట్ థర్డ్ మ్యాగ్నెటిక్ మూమెంట్ క్యాన్సిల్ అవ్వచ్చు, కానీ ఫోర్త్ ఎగ్జిస్ట్ అవుతుంది. అలాగే ఫిఫ్త్ అండ్ సిక్స్త్ క్యాన్సిల్ అవ్వచ్చు. సో ఫస్ట్ అండ్ ఫోర్త్ డైపోల్ మూమెంట్స్ అనేటివి ఎగ్జిస్ట్ అవుతున్నాయి కాబట్టి నెట్ డైపోల్ మూమెంట్ మ్యాగ్నెటిక్ మూమెంట్ అనేది ఎగ్జిస్ట్ అవుతుంది. This is another picture which compares arrangement of domains in three different substances. They are ferromagnetic substances, antiferromagnetic substances, and ferrimagnetic substances. So in this first line you can see arrangement of domains in ferromagnetic substance. All domains are in upward direction and therefore they are strongly attracted by the magnetic field. So they are said to be ferromagnetic substances. In the second line, the alignment of domains are seen in alternate directions. So one is upward, the next one is downwards, and the immediate next one is upwards and again downwards. So because of this alternate arrangement of domains in equal and opposite directions, the net magnetic field exhibited by antiferromagnetic substances are zero. Still, you can see domains in these substances as they are seen in ferromagnetic substance. The third line shows alignment of domains in ferrimagnetic substance. Here, how many upward arrows are there? 1, 2, 3, and 4. How many downward arrows are there? 1 and 2. So, totally 4 domains are in upward direction and 2 domains are in downward direction. Therefore, the resultant magnetic moment exists and they are said to be weakly attracted by the magnetic field.
Okay, sister,
this is the final picture which shows a comparison of different magnetic material and their properties.
my name is Sai.
So the first column shows properties, second description, third alignment, fourth example, and fifth uses. First, diamagnetic substances. They are weakly repelled by the magnetic fields. Paramagnetic substances are also weakly attracted by the magnetic fields. Ferromagnetic are strongly attracted by the magnetic field and they can be permanently magnetized, which means even after removing external magnetic field, magnetism exists in the substance. Antiferromagnetic substances have zero magnetic moment. Ferrimagnetic substances possess small magnitudes of magnetic moments. How about the alignment seen here? Diamagnetic substances have all electrons in the orbitals are paired and are completely filled. Therefore, they are weakly repelled by the magnetic field. Example, sodium chloride, benzene, etc. And they behave like insulator. Paramagnetic substances contain at least one unpaired electron in the orbital. So because of less number of unpaired electrons, they are weakly attracted by the magnetic field. Once the external magnetic field is removed, it loses its magnetic property. Examples are O2, Cu2+, etc. Paramagnetic substances are used in electronic appliances. Then ferromagnetic substances have unpaired electrons which are present in all possible directions. So ferromagnetic substances have unpaired electrons all having the same direction. So because of more number of unpaired electrons present in them, they exist as strong magnets. Even after removing external magnetic field, these substances exhibit strong magnetic property. Example, cobalt, nickel, chromium oxides, etc. So one of the applications of it is CrO2 is commonly used in making cassette recorder. Antiferromagnetic substances. Dipole moments are arranged in a compensatory way. Compensatory way in the sense, one domain in upward direction, the next domain in downward direction. If such kind of arrangement is seen, then it is said to be antiferromagnetic substance. Because of the compensatory arrangement of dipole moments, the net magnetic moment of it is zero. Examples are oxides of nickel, manganese, vanadium, etc. Next, ferromagnetic substances. Unequal number of parallel and antiparallel arrangement of magnetic moments are seen. As we have seen in the previous picture, 4 upward domain directions and 2 downward domain directions. So this is said to be unequal number of arrangement. And because of that, these substances possess small magnetic moments. This is the overall view of all 5 types of magnetic substances. So with that, the magnetic properties of substances is over. If we see the revision of the same concept, magnetic properties of solids are due to movement of electrons present in them. So there are 2 possible movements of electron about the nucleus. Around the nucleus, if it revolves around the nucleus in one particular shell, it is one kind of a motion. And if the electron spins about itself, that is a second type of a motion. Due to these two different motions, it exhibits magnetic property. In this picture, you can see the electron revolving around the nucleus. And in the second picture, you can see the rotation of electron by itself in one particular spin direction. So, a magnetic moment of a substance is measured in units of Bohr magneton, represented by mu b. 1 Bohr magneton is equal to 9.27 into 10 to the power of minus 24 ampere meter square. There are 5 different magnetic substances: paramagnetic, diamagnetic, ferromagnetic, antiferromagnetic and ferrimagnetic substances. Paramagnetism is shown due to the presence of one or more unpaired electrons in the atom. It is a temporary magnet. By applying external magnetic field, it is weakly attracted. By removing the external magnetic field, it is again regaining its original nature. Diamagnetic substances are weakly repelled by the magnetic field. And diamagnetism is due to the presence of all paired electrons. If unpaired electrons are zero, then they exhibit diamagnetism. Ferromagnetism is understood by domains. Domains are group of ions present in small regions, and each region, each domain acts as tiny magnet. If all domains are aligned in one particular direction, then the substance is said to be ferromagnetic. It is said to have strong magnetic field. Here you can see the comparison between paramagnetic and ferromagnetic substances. In paramagnetic material, you can't see any domains. In ferromagnetism, there are different domains which are seen here. In each domain, the ions are directed in different directions. By applying external magnetic field, in both paramagnetic substances as well as ferromagnetic substances, they try to be arranged in one particular direction. Antiferromagnetism has domains as it is seen in ferromagnetic substances, but arrangement of domains are in a compensatory way. If one is in upward direction, the next one is in downward direction, which results in cancellation of each other. Ferrimagnetism is nothing but those substances which are weakly attracted by the magnetic field. And they are weakly attracted because they don't have arrangement of domains in an exactly compensatory way. Here in this picture, you can see 4 domains in upward directions and 2 domains in downward directions. Therefore, net dipole moment exists. Therefore, the magnetic moment of the substance results in ferrimagnetic property of the material. This is the comparison of 3 different substances: ferromagnetic, antiferromagnetic and ferrimagnetic. Again, the same thing is seen. In ferromagnetic substances, all domains are seen in upward directions. In antiferromagnetic, alternate compensatory arrangement of domains are seen. In the last one, ferrimagnetic substance, not exactly compensation of each magnetic dipole is seen. The net dipole moment is not equal to 0. Therefore, magnetic moment is observed in ferrimagnetic substances. So this is the overview of the topic magnetic properties. Thank you all for allowing me to complete this session smoothly.
Thank you, madam.
Okay. Thank you, ma'am.
Thank you,
Thank
ma'am.
you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you so much, ma'am.
Thank you, ma'am.
If you have any doubts, you can ask me. Otherwise, we'll wind up the session.
డొమైన్ గురించి ఒకసారి చెప్పండి మ్యామ్.
Okay. డొమైన్స్ అనేవి ఫెరోమాగ్నెటిక్, యాంటీఫెరోమాగ్నెటిక్ అండ్ ఫెరీమాగ్నెటిక్ సబ్స్టెన్సెస్ లో కనిపిస్తాయి. సో ఇవేంటంటే గ్రూప్ ఆఫ్ అయాన్స్ ఒక పర్టికులర్ రీజన్ లో ఒక దగ్గర చేరి టైనీ మ్యాగ్నెట్స్ లాగా, అంటే చిన్న చిన్న మ్యాగ్నెట్స్ లాగా తయారవుతాయి. సో ఇది మొత్తం సబ్స్టెన్స్ అనుకుంటే దీంట్లో 4 డొమైన్స్ ఉన్నాయి. సో ఈ 4 డొమైన్స్ లో ఒక గ్రూప్ ఆఫ్ అయాన్స్, ఒక పర్టికులర్ డొమైన్ లో ఉన్న గ్రూప్ ఆఫ్ అయాన్స్ అన్ని ఒక డైరెక్షన్ లో అలైన్ అయి ఉంటాయి. ఇంకొక డొమైన్ లో చూస్తే ఇంకొక సెట్ ఆఫ్ గ్రూప్ ఆఫ్ అయాన్స్ అన్ని ఆ రీజన్ లో ఒకే డైరెక్షన్ లో అలైన్ అయి ఉంటాయి. సో ఇలాగా డిఫరెంట్ డొమైన్స్ అంటే ఏంటి? డొమైన్స్ హ్యావ్ a group of ions in one particular region which are aligned in a same direction, in which all ions are aligned in same direction. వాటిని డొమైన్స్ అంట. ఈ డొమైన్స్ absence of external magnetic field లో అయితే వేరే వేరే డైరెక్షన్స్ లో ఉంటాయి. ఒక్కొక్క డొమైన్ ఒక్కొక్క డైరెక్షన్ లో ఉంటుంది. అదే ఎక్స్టర్నల్ మ్యాగ్నెటిక్ ఫీల్డ్ అప్లై చేసినప్పుడు అన్ని డొమైన్స్ కూడా ఒకే డైరెక్షన్ లో అలైన్ అవుతాయి. ఇలాంటిది మనం ఫెరోమాగ్నెటిక్, ఫెరీమాగ్నెటిక్ అండ్ యాంటీఫెరోమాగ్నెటిక్ లో చూస్తాం. సో ఫెరోమాగ్నెటిక్ లో అన్ని పైకే ఉంటాయి, అన్ని అప్వర్డ్ ఆరోస్. యాంటీఫెరోమాగ్నెటిజం లో 1 అప్వర్డ్ 1 డౌన్వర్డ్ డొమైన్స్, అంటే కాంపెన్సేటరీ వేలో ఉంటాయి. ఫెరీమాగ్నెటిక్ లో అన్ఈక్వల్ నంబర్ ఆఫ్ కాంపెన్సేటరీ వే చూస్తామన్నమాట. అంటే 4 అప్వర్డ్ డొమైన్స్ ఉంటే 2 డౌన్వర్డ్ డొమైన్స్ ఉంటాయి. ఆ విధంగా డైపోల్ మూమెంట్ ఎగ్జిస్ట్ అవుతుంది. సో మ్యాగ్నెటిక్ మూమెంట్ కూడా ఉంటుందన్నమాట. The ions of ferromagnetic substances group together in small regions to act like a tiny magnet. This small magnetic region is called a domain.
ఇంకేమైనా డౌట్స్ ఉన్నాయమ్మా?
డయామాగ్నెటిజం చెప్పండి టీచర్.
ఓకే మా. సో డయామాగ్నెటిక్ ప్రాపర్టీ అనేది ఎలాంటి సబ్స్టెన్సెస్ ఎగ్జిబిట్ చేస్తాయంటే, వేటిలో అయితే నంబర్ ఆఫ్ అన్పెయిర్డ్ ఎలక్ట్రాన్స్ 0 ఉంటాయో అవి డయామాగ్నెటిజం ని ఎగ్జిబిట్ చేస్తాయి. సో దే ఆర్ వీక్లీ రిపెల్డ్ బై ది మ్యాగ్నెటిక్ ఫీల్డ్ అండ్ here the weakly magnetized on the application of magnetic field in opposite direction. సో ఈ ఎలక్ట్రాన్స్ పేరప్ అయి ఉండడం వల్ల, సో ఒక ఆర్బిటల్లో 2 ఎలక్ట్రాన్స్ ఆఫ్ ఆపోజిట్ స్పిన్ ఉన్నప్పుడు ఏమవుతుంది? ఒక స్పిన్ క్లాక్ వైజ్ డైరెక్షన్ లో తిరుగుతుంది, ఇంకొక ఎలక్ట్రాన్ యాంటీ క్లాక్ వైజ్ స్పిన్ లో ఉంటుంది. సో ఆ రెండు ఒకదానికొకటి క్యాన్సిల్ అవ్వడం వల్ల మ్యాగ్నెటిక్ క్యారెక్టర్ ని లూజ్ చేసుకుంటాయి అన్నమాట. సో అలాంటి సబ్స్టెన్సెస్ ని డయామాగ్నెటిక్ సబ్స్టెన్సెస్ అంటాం. అండ్ దట్ ప్రాపర్టీ is called diamagnetism. So diamagnetism is due to the absence of unpaired electrons. Okay, Nama?
Okay, teacher.
Okay, Nana.